There's a planet made entirely of diamond, or at least that's what the model said. It's called 55 Cancri E. It's about 40 light years from Earth, and it is worth, if you could somehow mine it and bring it home, roughly $26.9 nonillion dollars. That number has 30 zeros in it. But that's not the weird part. The weird part is that according to everything we knew about how planets form, this planet should not be there. Its composition doesn't match the models. Its orbit doesn't match the models. Its temperature doesn't match the models. When astronomers found it, they didn't celebrate. They panicked. Because if this planet exists, then the models that predicted it couldn't exist are wrong. And if those models are wrong, then everything we thought we knew about how solar systems form is, at minimum, incomplete. We just ranked everything in your house by kill count. Now let's go somewhere where the kill count is measured in star systems. Before 1995, we had one example of a solar system, ours. 8 planets, orbiting at sensible distances, gas giants far out, rocky planets close in. The models were built on this single data point, and they were elegant. Dust and gas collapse into a disk. Heavy stuff accretes near the star. Lighter stuff accretes further out. Gas giants form beyond the frost line where there's enough volatile material to build something massive, clean, logical, testable. Then in October 1995, Michel Mayor and Didier Queloz announced the discovery of 51 Pegasi b, a gas giant the size of Jupiter, orbiting its star in 4 days. For context, Jupiter takes roughly 12 years to orbit the Sun. 51 Pegasi b was completing a full orbit in less time than it takes to get through a work week. It was so close to its star that its surface temperature was estimated at over 1,000 degrees Celsius. This was not supposed to be possible. Gas giants are supposed to form far from their stars, where it's cold enough for gas to accumulate. A gas giant that close should have been incinerated during formation. It should not be there. It was there. Mayor and Queloz won the Nobel Prize in 2019, not for confirming the models, but for proving them wrong. 51 Pegasi b was the first hot Jupiter. Since then, astronomers have found hundreds, gas giants in orbits that take days instead of years, surface temperatures high enough to melt lead, atmospheres being actively stripped away by stellar radiation. The current leading theory is that these planets formed further out, where the models said they should, and then migrated inward through gravitational interactions. The models weren't entirely wrong. They were missing a chapter. The universe builds planets where we expected, and then moves them to places we didn't. But migration explains position. It doesn't explain composition, which brings us to the planets that are made of things that shouldn't exist in planet form. 55 Cancri E, 40 light-years away, in the constellation Cancer, roughly twice the diameter of Earth, about 8 times the mass. It orbits its star in 18 hours. A year on 55 Cancri E is shorter than a day on Earth. Its surface temperature on the star-facing side is roughly 2,500 degrees Celsius. Hot enough to melt titanium. And for years, the prevailing model based on its mass, radius, and the composition of its host star suggested that a significant portion of this planet was crystallized carbon. Diamond, an entire world where the mantle, the layer beneath the surface, may be made of solid diamond hundreds of kilometers thick. This broke the compositional models because Earth-type planets were assumed to be silicate-dominant, rock, iron, magnesium. A carbon-dominant planet requires a host star with a carbon-to-oxygen ratio that was considered unusual. Turns out, it's not unusual. It's just not what we were looking for. So the models got rewritten. Diamond planet, case closed. Then in 2024, the James Webb Space Telescope pointed its instruments at 55 Cancri E and found something the revised models didn't predict either: a volatile atmosphere, likely rich in carbon dioxide or carbon monoxide, sustained by an underlying magma ocean. The diamond mantle theory, the one that had already forced a rewrite of planetary formation models, was itself probably wrong. The models got broken, got fixed, and got broken again. By the same planet. The universe is rewriting our textbooks in real time, and it's not even being subtle about it. From diamonds to glass. HD 189733b is 63 light-years away, and it is one of the most studied exoplanets in history because it is one of the most violent places ever observed. The planet's atmosphere contains silicate particles. Silicates, at the temperatures present in HD 189733b's upper atmosphere, condense into small glass-like droplets. The planet's wind speeds reach approximately 7,000 kilometers per hour. For context, the fastest wind ever recorded on Earth was around 408 kilometers per hour during a tornado. HD 189733b is 17 times faster than that. Those glass particles are being driven sideways through the atmosphere at hypersonic speeds. It rains glass, sideways, at 7 times the speed of sound. From orbit, the planet looks like a calm blue marble, similar to Earth. The blue color is not water. It is the light being scattered by trillions of glass shards in the upper atmosphere. It's the prettiest murder machine astronomers have ever photographed. WASP 76b takes the weather in a different direction. This planet is roughly 640 light-years away and is tidally locked. One side always faces its star. One side always faces away. The day side reaches temperatures around 2,400 degrees Celsius, hot enough to vaporize iron. Actual metallic iron becomes gas on the day side, rises into the atmosphere, gets carried by global wind patterns to the night side, where the temperature drops to roughly 1,500 degrees, still absurdly hot by Earth standards, but cool enough for iron vapor to condense back into liquid. It rains iron. Molten iron falling from the sky on the night side of a planet where the evening forecast is permanently ___, quote _0__. When astronomers published this finding in 2020, the paper's title was remarkably restrained for a discovery that essentially confirmed the existence of a planet where the weather is made of liquid metal. Every planet so far is strange, but at least fundamentally alive. Orbiting active stars, maintaining atmospheres existing in functioning solar systems. PSR B1620-26b doesn't have that luxury. This planet orbits a binary system consisting of a pulsar and a white dwarf, 2 dead stars. The pulsar is the rapidly spinning remnant of a star that exploded. The white dwarf is the cooling corpse of a star that ran out of fuel. The planet orbits both of them. It's roughly 12.7 billion years old, nearly as old as the universe itself. For most of its existence, the universe didn't have the heavy elements needed to build planets like Earth. This planet predates those elements by billions of years. Astronomers call it the Methuselah planet. It has survived 2 stellar deaths. It has watched its stars explode and collapse and still maintained its orbit. This planet has been circling dead things since before the Milky Way had its current shape. It is, by any reasonable definition, a ghost orbiting ghosts. Trieste 2b is the one nobody can explain. This planet is roughly 750 light-years from Earth, and it absorbs more than 99% of all light that hits it, making it the darkest planet ever discovered. Darker than coal. Darker than any known material on Earth's surface. For comparison, our moon reflects about 12% of the light that hits it. Trieste 2b reflects less than 1%. In theory, if you were floating near it, you would see almost nothing, a faint dark red glow, like an ember in a dead fireplace, surrounded by absolute blackness. The leading hypothesis involves light-absorbing chemicals in the atmosphere, vaporized sodium, potassium, titanium oxide, but the models using those chemicals still can't account for how dark it is. The numbers don't reach 99%. There is something absorbing light on that planet that we haven't identified yet, which means either our atmospheric chemistry models are incomplete or there is something in that atmosphere that we don't have a name for. 7 planets. 7 things that the textbook said couldn't happen. Hot Jupiters that migrated from sensible orbits to impossible ones. A diamond world built on a carbon ratio we assumed was rare. Glass rain at 7 times the speed of sound. Iron precipitation on a planet that's too hot to have liquids, except that it does. A ghost planet older than most of the universe's stars. And a world so dark that the physics of light absorption can't fully explain it. Every one of these discoveries followed the same pattern. Find something that contradicts the model, try to fix the model, realize the model was built on a sample size of 1 our solar system, and accept that one example was never going to be enough. The history of exoplanet astronomy is a history of confident predictions being systematically dismantled by observation. We assumed gas giants form far from stars. Wrong. We assumed rocky planets are silicate-based. Sometimes wrong. We assumed planets need living stars. Wrong. We assumed we understood atmospheric chemistry well enough to predict reflectivity. Wrong. This isn't a failure of science. This is science working exactly as designed. Models are supposed to break when new data arrives. But there's a version of this story that's worth sitting with for a second. Every model of the universe that humans have ever built, from Ptolemy's crystal spheres to Newtonian gravity to modern planetary formation theory, was the best available approximation at the time. Each one was confidently taught, widely accepted, and eventually replaced by something that explained more. There is no reason to believe the current models are the last ones. The models we have now are not the truth. They're the least wrong version of reality we've managed to build so far. And somewhere out there, right now, there is a planet doing something that will require the next rewrite.